24M's mission is to provide our customers with everything they love about lithium-ion batteries, but at a price that they can also love.
Imagine driving 1,000 miles on a single charge, then pulling into a regular station, plugging in, and 4 minutes later, 200 miles back in your battery. No bulky megawatt chargers or hour-long waits. Sounds like science fiction, right? It's not. At the heart of it is 24M Technologies, a quiet but powerful American battery innovator. Their new semi-solid battery platform and this mysterious Eternalite electrolyte are total game changers. And to stir the pot even more, Elon Musk might have just leaked exactly what Tesla plans to do with it. So, what makes this battery so powerful, fast and different? Let's pull back the curtain and break it all down. Inside the 1,000-mile battery. What is Eternalite? It all comes down to one word that sounds like it was pulled from a sci-fi novel. Eternalite. At first glance, that name sounds more like a bottled water brand from the 80s, but in reality, it's a next-gen electrolyte developed by 24M Technologies, and it might just be the final puzzle piece for the electric vehicle breakthrough everyone's been waiting for. Because here's the deal. All batteries rely on electrolytes to shuttle ions back and forth between electrodes. That's how energy flows. But most of the ones we use today, especially in EVs, have a pretty big limitation. They're decent at conductivity, safety, or charging speed, but rarely all three. Eternalite changes that. What 24M figured out was how to crank up ionic conductivity, basically how fast the ions can move inside the battery, by nearly 3 times compared to conventional liquid electrolytes. And just to make this feel real, think of it like water pressure in your pipes. Most electrolytes are like an old apartment building with thin pipes and inconsistent flow. Eternalite is more like a high-pressure fire hose. The result? Power moves faster, smoother, and cleaner through the system. That's the foundation of the speed you're about to see. Now, when 24M paired this Eternalite with their semi-solid battery platform, something wild happened. You get 4 times faster charging without frying the battery or needing a futuristic megacharger the size of a truck. It means adding more than 300 kilometers, or just under 200 miles of range, in under 4 minutes. And we're talking with chargers that are already out there. Your standard 400-volt and 800-volt public chargers. No special infrastructure, no sci-fi gas station in the desert. Just plug in, stretch your legs, and your EV is ready for another 2-hour drive before you've even finished a snack. But here's where things really get personal for EV drivers. Cold weather. If you've ever driven an electric car in winter, you know the pain. The range drop, the sluggish response, the battery that just doesn't want to wake up. But Eternalite was designed to handle extreme cold in a way other electrolytes can't. In lab tests, it retained 80% of its capacity at minus 40 degrees Celsius. That's the kind of temperature where your eyelashes freeze, and most batteries start crying for help. But Eternalite just keeps moving ions like it's nothing. And what makes all this even more impressive is how seamlessly it fits into the battery world we already have. You don't need to rip up manufacturing lines or reinvent the wheel. Eternalite works with existing lithium-ion battery materials, including lithium metal, silicon, and graphite. So whether a manufacturer's working with next-gen solid-state designs or tweaking legacy systems, this stuff drops right in. It's like upgrading your phone's software to make it twice as fast, but without changing the hardware. The guy behind this breakthrough, Naoki Ota, CEO of 24M, put it pretty plainly. He said this isn't just a marginal improvement, this is a platform that could enable 1,600 kilometers of range. That's about 1,000 miles on one charge. He also talked about long cycle life, which means batteries that don't just go far but last for years without significant degradation. Think about what that means. No more range anxiety, no more hunting for a charger every few hours, and way fewer battery replacements over the vehicle's lifetime. Let's zoom out for a second. This isn't some proof of concept buried in a lab. 24M's Eternalite is already integrated into working prototypes, and companies are starting to pay close attention. And then there's the Elon factor. According to a few well-placed whispers, Musk may have already seen what this electrolyte can do, and some suspect the next Tesla innovation wave may quietly ride on Eternalite's shoulders. If that's true, we're looking at a serious pivot in battery dominance coming from the US, not China, not Germany, but right here. Have you ever had to sit in a freezing car watching your EV's range shrink in real time? Or maybe you've stood at a charger for what felt like forever, just to top up a little juice? But how does this actually compare to Tesla's current 4680 battery, or what other automakers are cooking up behind closed doors? Tesla 4680 versus 24M Eternalite. Tesla's 4680 battery was supposed to be the breakthrough, the thing that finally closed the gap between EVs and traditional gas cars, not just in range but in price, production and performance, and for a while it held that crown. But now, the game may have shifted, because while Tesla's Gen 1 4680 battery tops out around 244 watt-hours per kilogram, 24M's new battery, powered by its Eternalite electrolyte, is claiming 660 watt-hours per kilogram. That's nearly 2.7 times more energy stored in the same amount of mass. If that sounds abstract, let's make it tangible. Imagine two batteries, same size, same weight. One gets you from San Francisco to LA, the other from San Francisco all the way to Seattle without charging. That's the scale of change we're talking about here. And for EV drivers, that's the difference between needing to plan your trip around chargers or just driving like you always have. Now, let's talk charging. Tesla's superchargers are fast, no doubt. Most drivers can expect about 200 miles added in maybe 20 to 30 minutes, and that's on a good day with a warm battery at a high-capacity stall. But Eternalite throws that timeline out the window. In the lab, it's delivering the same 200 miles of range in under 4 minutes. That's less than the time it takes to order coffee and wait for it at a busy drive-thru. And here's the kicker. It's doing it on standard 400-volt or 800-volt infrastructure. No megawatt-scale chargers needed. No new power grid installation required. It's like plugging in your phone and watching it hit 50% before your thumb leaves the screen. Where Eternalite really starts to flex, though, is in extreme conditions. Cold weather is a known enemy of lithium-ion batteries. Even Tesla owners know the drill. Range drops, charge rates slow down, and suddenly your 20-minute top-up turns into a full episode of a show. But 24M's electrolyte keeps more than 80% of its capacity even at minus 40 degrees Celsius. That's frozen windshield fluid territory. That's your door won't open cold. And yet the battery still performs almost like it's summer. Now, just to ground this in the larger landscape, Tesla isn't the only name in the battery race. Companies like CATL in China, LG Energy Solution in South Korea, BYD, Panasonic, and Samsung SDI are all vying for dominance. But right now, most of their energy densities hover between 200 and 300 watt-hours per kilogram. Even CATL's new condensed battery only promises around 500. So when 24M's semi-solid battery claims 660, that's not just a step up, it's a vertical leap. And here's something most people don't realize. 24M's battery isn't a completely alien system. Its design is modular and flexible. It can be integrated into existing 4680-style production lines. That means Tesla wouldn't need to tear down and rebuild its entire manufacturing infrastructure to use this. The tooling, the layout, even the automation could stay the same. They'd just be swapping in a new chemistry. It's like keeping your laptop, but replacing the processor with something 3 times as fast and twice as efficient. Which brings us to the whispers. There's been talk, leaks, subtle remarks, even a few slips in earnings calls that Tesla is aware of this tech, that they've looked at Eternalite, maybe even tested it. Elon Musk hasn't confirmed anything outright, but let's be real. When something this powerful, this scalable and this American-made shows up, it will get their attention. The real question is whether they'll partner up, license the tech, or just quietly acquire someone to get it in-house. Would you jump on that upgrade if Tesla adopted Eternalite and pushed the range past 1,000 miles with 4-minute charging? Or do you think they'll stick to improving the 4680 in-house? But despite everything, is this breakthrough really ready for mass production? Or is it still stuck in the lab? Production, partnerships, and market impact. It's one thing to invent a breakthrough in a lab. It's a whole different level, an entirely new era to produce it at scale. So, let's take a nighttime drive through 24M's story, exploring how a quiet startup based near Boston is gearing up to face the world's battery giants and reshape the US energy landscape. Night settles over Cambridge, Massachusetts. Inside a 140,000 square foot facility, 24M engineers are fitting electrolyte chemicals and semi-solid electrodes into pilot lines. That plant is on track to ramp up to 200 megawatt hours per year by the end of 2025, meaning enough batteries to power about 6,000 electric vehicles annually. But that's just the start. Meanwhile, halfway across the globe in Japan, Kiosera, 24M's license partner, is doubling its factory output. Their Shiga Yasu plant will go from 20,000 units to 400 megawatt hours per year by fiscal 2026, backed by a 10 billion yen investment. This is a sign that this isn't just experimental hype, it's global demand at work. This isn't about building a factory from scratch, it's about licensing and sharing the secret sauce. 24M's semi-solid process is set up so any factory in Japan, the US, Europe can plug it into existing assembly lines without tearing everything down. And that's huge because global brands like Kiosera can deploy it quickly without risk. Zooming out, the battery world looks like a big power grid, with China providing about 75% of global capacity. Tesla, for example, sources about 40% of its batteries from Chinese suppliers today. That's a serious geopolitical vulnerability. That makes 24M's US-based facility even more strategic. Combine that with new production ramp-ups, and suddenly American EVs are backed by American batteries. That's not by accident. Remember the Inflation Reduction Act, which handed out tax credits for domestic manufacturing and deep supply chains. It's a direct response to this gap, encouraging startups like 24M to build, partner, and stay here. And the US battery boom isn't just a story of small innovators, it's massive. 10 new battery plants from companies like Panasonic, Samsung, LG, SK On, Toyota, and Ford are scheduled to come online in 2025. Collectively, they're projected to boost US battery capacity to 421.5 gigawatt hours per year, nearly double what the country had just a year before. That's enough juice to power about 5 million EVs every year. When you see a modern Tesla, Ford Lightning, Chevy Bolt, or even a Toyota BZ4X on the road, there's a good chance its battery came from one of these new plants, or will soon. That massive build-out undercuts China's dominance and gives America supply chain independence. A quiet shift is happening behind the scenes. What started as a lab breakthrough is now turning into something much bigger. With Kiosera doubling down on production, US battery plants scaling up, and fresh funding pouring in from government programs, this technology isn't just promising, it's moving. And with global supply chains under pressure and China still controlling a major slice of battery materials, the stakes for American-made energy storage have never been more serious. I want to hear from you. Do you think real EV independence will happen once the batteries are made in America? Or is it just greenwashing with stickers? However, while chemistry is powerful, real genius might be in the business model. Because this isn't just a battery breakthrough, it's a licensing play that's spreading like wildfire under the radar. What 24M is doing isn't just engineering, it's franchising a future. Instead of hoarding the tech in one shiny factory, they're licensing the Eternalite platform to other battery makers worldwide. That's what makes it different from the secretive arms race happening between legacy automakers and battery giants. Think of it more like Android for batteries, a flexible ecosystem that anyone can build on. Kiosera saw this early. They signed on, not just to buy Eternalite batteries, but to make them themselves using 24M's chemistry. That's the hidden source. It's not just about one company winning, it's about a flood of battery producers upgrading their lines overnight without tearing down infrastructure. Because of that, this isn't limited by factory space or even geography. The tech can be licensed in Detroit, Tokyo, or Stuttgart, and the performance jump still holds. And here's where things get even more interesting. The companies licensing this tech aren't all disclosing it publicly yet, but we can trace it. Job listings in places like Korea and Germany, new electrolyte purchasing contracts, and R&D announcements that mention semi-solid formats and drop-in compatibility. The trail is there. In a way, Eternalite isn't just a chemical, it's a distribution model. It's a quiet, almost invisible rollout strategy that could flood the market before the big players even finish their solid-state prototypes. This means that the revolution may not look like a single event, but a tipping point that we only recognize in hindsight. So, if these quiet licensing deals are already in motion, if the signs are in job boards and supply chains, not headlines, then maybe the real race isn't about who builds the best battery from scratch, but who upgrades fastest without anyone noticing. Could the biggest shift in battery history be happening in plain sight? The stealth revolution. It didn't start with fireworks. There was no flashy announcement, no Elon tweet storm, just a quiet update buried in an engineering report and a license agreement signed with a Japanese partner. But hidden inside that calm rollout was a feature that might change everything. For M's Eternalite isn't just another battery upgrade. It's something deeper, something that doesn't demand billion-dollar factories or sci-fi breakthroughs. Instead, it offers something surprisingly low-key: compatibility. And that's the part barely anyone is talking about. What Eternalite does, at its core, is sidestep the rules that usually hold battery tech back. This isn't a complete teardown and rebuild. You don't need to gut existing assembly lines or redesign your car around it. The chemistry slips into place. Drop it into a lithium metal battery. It works. Plug it into silicon anode tech. Still works. Even traditional graphite-based cells get the upgrade. It's flexible by design. Now, here's where it gets wild. That adaptability isn't just convenient, it could be a multiplier, the kind that jumps performance not by a small margin, but by 2 to 4 times. Imagine your current EV doubling its range or slashing its charge time in half without changing the chassis, charger, or factory layout. Tesla, for instance, could upgrade its 4680 cells overnight, not in a future roadmap or beta testing lab, right now. The dry electrode process they already use is compatible. The factory floor wouldn't need to be reinvented. It's the same line, just more innovative materials. And once that lands, the ripple effect becomes hard to ignore. Every major OEM chasing solid-state promises suddenly has a choice. Wait another 8 years for full solid-state adoption, or plug Eternalite chemistry into existing designs and leapfrog the timeline, not by brute force, but by clever retrofitting. It would make EV performance jump years ahead without needing megawatt charging stations or full ecosystem overhauls. That means faster charge times on the current infrastructure. No waiting for new hardware, no billion-dollar bottlenecks. Even the grid feels the shift. If a car can recharge 200 miles in under 4 minutes without stressing the system, the demand curve flattens. High-speed charging isn't limited to luxury corridors with super-fast stations anymore. It starts looking doable at the edge of town, in rural stops, in regular driveways. The story gets even more interesting when you follow the partnerships. Kiosera isn't just testing Eternalite, they've doubled their production. They're building it at scale now, not as a pilot, not as a trial. Real volumes, real customers. Other global players have signed licensing deals, though most haven't named themselves publicly yet, but the clues are in supply orders, factory tooling, and job listings. That's why this might be less of a tech debut and more of a stealth revolution, not a moment where everything changes at once, but a quiet fuse that's already lit. It doesn't just promise new performance, it makes old designs suddenly more relevant. And with no need for exotic materials or heavy retooling, Eternalite offers speed, which most battery upgrades don't. So, what happens when a single chemical tweak makes yesterday's battery lines outperform tomorrow's solid-state dreams? Tesla could move first, or maybe a smaller, hungrier player leaps ahead while the giants hesitate. Either way, the balance shifts. This isn't just a better battery, it's a silent rewrite of the rules, a universal upgrade hiding in plain sight. And if Eternalite really is the key, then the future of EVs may have already changed, quietly, irreversibly, before anyone even realized it. A battery that takes you 1,000 miles on one charge, 200 miles topped up in 4 minutes, built in the US, ready to slot into nearly every EV factory on the planet. That's not just innovation, it's transformation. With Eternalite, we're looking at faster charging, longer range, better winter performance, and maybe even a shift toward real battery independence in the US. And if Tesla really does jump in, this could speed up the EV transition way faster than anyone predicted. What EV would you want with this battery? Drop your dream car in the comments.